Still looking at projectile motion, but now we're going to take a different approach to it. Remember, we started with the accelerations and we integrated, and these became the general formulas for displacement and velocity in both the horizontal and the vertical direction. If you look at the displacement, what we've really got there are parametric coordinates of a parabola. And of course it's a parabola, because we saw that the path of our projectile is indeed a parabola. So all right, let's find the actual Cartesian equation. So if I make t the subject in the horizontal displacement, I'll get x over v cos theta. Sub that into y. Well, bit of trig identity work here to do. We've got things like sine on cos. We've got cos squared on the bottom of the first fraction. So we'll change that reciprocal of cos squared is sec squared. Sine on cos is, of course, tan. Might go a step further. Let's change the sec squared to be 1 plus tan squared. And there we have a nice equation. The only trig value there is tan. The only reason I changed the sec squared to be tan squared plus 1 was to get a consistent trig ratio into the equation. We could, of course, have left it as sec squared. So back to our common questions now. If we're treating it as a Cartesian equation, when we ask the range of the particle, our parabola, our quadratic, well, that's going to be the roots or the solutions of the quadratic. So with the sec squared, rearranging that, and you'll notice now I've got tan back to sine on cos, but I can factorise out the x on cos theta, and I get two possibilities. Either x is equal to 0, or x is 2v squared sine theta cos theta on g. So x is v squared on g, and 2 sine theta cos theta, well, that's sine 2 theta. So x equals v squared on g sine 2 theta. Interestingly, that now proves that the maximum range happens when theta is 45 degrees. Because when theta is 45 degrees, that sine function will become the sine of 90, and of course that is the maximum of a sine function. Okay, greatest height of the particle. Well, that's the vertex of our parabola. So all I'm interested in the y value, which remember we can find with minus the discriminant over 4a. So substituting that in, we get tan squared over 4 minus g sec squared or 2v squared. Let's play around with that. And we have the greatest height is v squared sine squared on 2g. What angle does the particle make with the ground? Well, now we're going to find the slope of the tangent. You'll recall that the velocity vector at any particular point, it's a tangent to the curve. So if we find the slope of that tangent, and then we just use the basic idea that slope is tan theta. Let's look at our example from yesterday. The ball's thrown with initial velocity 25, angle was whatever the inverse tan of 3/4 was. So now, let's find the Cartesian equation of our one from yesterday. We came up with x was 20t, so we'll make that t is x on 20, and we'll sub that into y, so the equation of the parabola is y equals minus x squared on 80 plus 3x on 4. So what is the greatest height then? Let's go and solve the problems from yesterday. Greatest height is the y value of the vertex, minus the discriminant on 4a, bang. 45 on 4 comes out a lot quicker. Range, well, they're going to be the solutions to the equation. So if we solve this little quadratic, we get that either x is 0 or 60. Well, we know it started at 0, so the range must be 60. The velocity in the direction after half a second. All right, well, we're going to have to find the equation of the tangent here to get that velocity vector. So dy dx is minus x on 40 plus 3/4. Now, after half a second, let's find all those values. Well, x is equal to 10, so dy dx ends up being a half. So tan theta is a half, and we get our angle of 26 degrees 34. Now, velocity, that's going to be x divided by t cos theta. Now, I'll just draw a little triangle up there so I can work out cos theta. You know, tan theta we just found out was a half. So the hypotenuse will be root 5. So there we get our velocity of 10 root 5. So there's the solutions to the same questions that we looked at yesterday, but now by treating it as a quadratic or a parabola. So if possible, finding the equation of the parabola itself can actually simplify a lot of these questions. All right, let's have a look at these ones from 3H.